Okay, so here are some of the problems we went over in class on the second day of 3.5, the proofs. So we worked on these together. So the first proof is given that for angle 4 is congruent to angle 5, prove that G and H are parallel. Now there are two ways to go about this. One is a very simple one. G and H are a pair of alternate exterior angles. We have a pair of alternate exterior angles that are congruent, therefore the lines are parallel. The other way is this, is to catch that 4 and 6 to be congruent through vertical angles, and that 6 and 5 are parallel because they're corresponding angles. But really the easiest way to do this proof is, given angle 4 is congruent to angle 5, 2, G is parallel to H because the corresponding angles converse. And you can't say, or sorry, not the corresponding angles, the alternate exterior angles converse. Right. Again, you can't just say alternate exterior angles. The converse states the other way around for us. Okay. Next one to take a look at. It's got a little more going on to it. Okay. So we are given that angle that WX and YZ are parallel. So WX, YZ are parallel. And we're given that angle 2 is congruent to angle 3. Our goal is to prove that WY and XZ are parallel. So I'm going to highlight those. Well, the real trick in this problem is knowing, hey, since these two, the WX and YZ are parallel, let me extend this. I'll use pen to do that so it stands out a little more. Hey, guess what? I've got a set of parallel lines. Okay, this line, and I've got a transversal of WY. That means angle 1 has to be congruent to angle 3. And if 1's congruent to 3, that means 1's congruent to 2 by transitive. And hey, if 1 and 2 are congruent, they are a pair of corresponding angles for WY and XZ. And there's our proof. Okay, so again, let me do it as the statements and reasons, and that was a lot I kind of unpacked there really quickly. 1 is given, WX is parallel to YZ, and then angle 2 is congruent to angle 3. I'm being really lazy about that. But our next step was this. Okay. Since WX and YZ were parallel, that means WY is a transversal. Angle 1 is congruent to angle 3 because alternate interior angles are congruent. If the lines are parallel, doing that kind of lazily. Step 3 then, once we know that, okay. Step 3 then, we know that if angle 1 is congruent to angle 3 and angle 2 is congruent to angle 3, angle 1 is congruent to angle 2 by transitive. Okay. And if 1 is congruent to 2, WY is parallel to XZ by the corresponding angles converse. Okay, that was number 2. Number 3, a very, very similar problem to number 2. So this is going to feel very, very similar, but it really is. This time, angle 1 is congruent to angle 3 to begin with. And AC is parallel to BD. What I want to prove is that line AB is segment AB is parallel to segment CD. Now, hopefully what's jumping out to you now, because we've looked at a couple of these, is, hey, there's a third angle in there, and how's that third angle related to anything? Well, it's related to 1 by being an alternate interior angle, related to 3 by being a corresponding angle. So the question is, which one is congruent and which one can I then therefore prove congruent through transitive? Well, the two lines we know are parallel are these two. So angles 2 and 3 are the ones we're going to talk about being congruent by corresponding angles. And now I've got a pair of alternate interior angles for those two segments of A, B, and C, D. So they're going to be parallel. So angle 1 is congruent to angle 3, given. And so is AC parallel to BD. 2, and again, this is the trickier part. Since AC and BD are parallel, that means that the corresponding angles must be congruent. So angle 2 is congruent to angle 3 by the corresponding angles postulate. Or you could just say corresponding angles are congruent. And again, this is my very sloppy angle with letter S. Now, to step 3, angle 2 is congruent to angle 1 by transitive. Okay. And angle 1 and angle 2 are a pair of alternate interior angles for AB and CD. So now I could say, hey, AB is parallel to CD by alternate interior angles converse. All right. Okay. Next problem, number 4. We're just plowing through these. Number 4. All right, this one is a pretty classic proof for this section. It's in lots of different textbooks, in our old textbook and our new one. We're given that angles 7 and 8 are 125 and 155 respectively. Prove that those two lines are parallel. Well, the key to this is recognizing that these two guys are consecutive interior angles. And then the question is, okay, what's special about consecutive interior angles, or what should be special about them if the lines are parallel? Oh, they have to be supplementary. So do 125 and 55 add to 180? Yes. So really that's the trick to this problem, is how do I explain that those two angles add to 180? So here's how we go about doing that in a 2-column proof. 1, given measure of angle 7 is congruent, not congruent, it's equal to 125. Measure of angle 8 is equal to 55. Now I wrote this way on purpose, not just because I'm sloppy and lazy. No, it was that way on purpose. Because step 2, I'm going to say, add those guys together. Measure of angle 7 plus measure of angle 8 is 125 plus 55. Oh, well, 125 plus 55 is 180. That's not the angle addition postulate, it's just the addition property. I just added both sides together. 3 then states, hey, if those guys add to 180, angle 7 and angle 8 are supplementary by the definition of supplementary angles, because they're two angles that had to be 180 degrees. And now I can say for step 4 that J is parallel to K because of the consecutive interior angles converse. Since the consecutive interior angles, 7 and 8, were supplementary, those two lines have to be parallel. Okay. All right then, let's look at the next one. Angle ABC is congruent to angle, ABC is congruent to angle ADC. Excuse me, so those two angles are equal. And angle A plus ABC has to add to 180. Now, it doesn't mean they're equal. This means they have to add to 180. And I want to prove then that AB is parallel to CD. Now, this one's tricky, especially the way it's drawn, because what would help is if you turned your page probably about, I don't know, 90 degrees or 70 degrees, and hopefully you'd see, oh, that looks like a pair of parallel lines. These guys here are a pair of consecutive interior angles, especially if I get my pen out again and I extend those. Aha! Let me stop there for a second so you can see it better because it's, yeah, focused. So that's my goal, is to show that these two guys are supplementary. Well, I already have a pair of angles that are supplementary. I know A and this guy are supplementary. But hey, I also know these two guys are equal, so I can replace this angle with this one. So that's going to be the hard part, is communicating all that. So again, starting off with the given. Okay. Now here's the next step. I need to replace angle A with angle, sorry, not angle A. I need to replace angle ABC with angle ADC. This one's fine. So what I'm going to do for step 2 then is say that the measure of angle ABC equals measure of angle ADC by definition of congruent. Okay. And then 3, this marker is terrible. It's very dull at the end. Let's see if this one's any better. Looks a little sharper. Then I can replace ABC with ADC. So the measure of angle A plus measure of angle ADC is 180 degrees. That is by substitution. And then 4 now, that means that angle A and angle ADC are supplementary by definition of supplementary angles. And that then means that AB is parallel to CD by consecutive interior angles converse. Oh, I ran out of space, sorry. Consecutive interior angles converse. So again, this was a tricky one. This one, I think the first 4 were pretty straightforward. That last one's kind of a weird twist you have to see of just knowing to add them together. But this one, I had to take that these angles were congruent and that these 2 angles were supplementary, which means that really these 2 guys are also parallel. I could also say that AD and BC are parallel. And in fact, this is a parallelogram. We'll talk about this in chapter 6 and all the special properties it has. But I'll first say these were equal by definition of congruent to do a substitution to replace ABC with ADC here. And then I know they're supplementary by definition of supplementary angles, and then they must be parallel by the consecutive interior angles converse. Okay. All right, last one, very, very last one for this section. Number 6, given that angle 1 is parallel or congruent to angle 2, and that what else we got? So we got angle 1. Yeah, angle 1 here is congruent to angle 2. And we know that LJ is perpendicular to ML. We want to prove that KM is perpendicular to ML. So I want to prove that there's a right angle here. Okay. All right. So here's how we're going to do this. And this one I hadn't looked at it for a while. So here's what we know. We have a line that's perpendicular to this line. Okay. And we also have a line or a pair of angles that are congruent. And these angles 1 and 2 are alternate interior angles. So what that means for us is, hey, we got a pair of parallel lines. Okay. So if one line is perpendicular to one parallel line, it must be perpendicular to the other. And this kind of fits in really with section 3.2, but we had to prove these lines are parallel first. That's why it's 3.5. So statements, reasons, 1, given, 2, LJ is parallel to KM by the alternate interior angles converse. And then step 3, I can just flat out say KM is perpendicular to ML because if 2 lines are parallel and one line is perpendicular to the transversal, so is the other. Okay. And there we go. So that was all the proofs from section 6. I know this is kind of sloppy written out. If you do have any questions, just come in and I can clear up what was going on. Thanks.